Okay, so this is section 7-2, and we're looking at systems of linear equations, but now in three variables. So we're going to have an x, y, and a z in our equations, and we have three equations here. So it's asking us to solve for x, y, and z, and our answers will always be written as a coordinate like this. And so what we're going to be doing is matching up equations and trying to eliminate a variable. So here, looking at which variable would be best for me to eliminate, I'm trying to think which ones would give me easy numbers to cancel out. And I think our best option here is probably z's. There aren't a lot of numbers that are going to be easy, but at least here, those two will be nice. So I'm going to start with these two equations. And as usual, I'm going to color code everything. So my first equation here is 5x minus 2y minus 4z equals 3. And I'm going to multiply this entire equation by 2 so that my z's can cancel out. So that'll become 6x plus 6y plus 4z equals negative 6. And when I add these two equations together, those cancel out. I have 11x plus 4y equals negative 3. And I'm just going to hang on to that for now. Now I have to use the equation I didn't use before, and then I can choose either one of these to group it with. It doesn't matter too much which one I choose. One's not really easier than the other, so I'm just going to choose that second equation. And in order for my z's to cancel out, I'm going to multiply my top equation by 3 and my bottom equation by negative 2. Now, it's really important to note here that you have to cancel the same variable out. If I canceled z before, I have to cancel z here. I can't choose x or y. So I have this bottom equation is being multiplied by negative 2. So that's going to be 4x minus 10y minus 6z equals negative 6. And then on the top we have let's see, 9x plus 9y plus 6z equals negative 9. Adding those together, we have our z's cancel, and we have 13x minus y equals negative 15. And again, I'm just going to hang on to that. Now what I want to do is I want to take these two equations here, and I want to bring them together and cancel out another variable. Now, obviously, y is a nice one here because it's just a 1. So I'm going to multiply this equation by 4 so that my y's will cancel. So 11x plus 4y equals negative 3. And multiplying this equation by 4, I get 52x minus 4y equals negative 60. And my y's cancel. I have 63x is equal to negative 63. So x equals negative 1. Now the nice thing is I can plug that into either one of these equations to solve for a y. I'm going to choose this one. You could choose either one. And I have negative 13 here. If I add 13 to both sides, I have negative 2 equals negative y, so y equals 2. And then it's just a matter of plugging in and finding our z value. So I'm going to go ahead and switch to another color. Here we have any one of these equations I can plug into. It doesn't matter which one. I'm going to choose the second one. So 3 times negative 1 plus 3 times 2 plus 2z equals negative 3. And then we have 2z equals negative 6 when we subtract those numbers over. And z equals negative 3. So our answer then is negative 1 to negative 3. Now, let's go ahead and look at our next example. We have an example that says, find the quadratic function y equals ax squared plus bx plus c, whose graph passes through these 3 points here. Now, at first, it might kind of seem overwhelming, but what we can actually do is set up some equations here. Now, they give us this equation right here where we have a, b, and c. And then they give us all these x and y values. So for the point -2, let me push this up a little bit. For the point -2, 7, I'm going to plug in -2 and 7 into this equation here. So I'll have 7 equals a times -2 squared plus b times -2 plus c. And then for -1, 2, and for 2, 3, I'll do the same thing. So I'll end up with -2 equals a times 1 squared plus b times 1 plus c. And then for this one, I will have 3 is equal to a times 2 squared plus b times 2 plus c. And now I can simplify all of these equations. I can distribute, multiply, and simplify things here. So I have 7 equals a times, let's see. Let's rewrite that a little bit. Of 7 equals 4a minus 2b plus c. I'll have -2 is equal to a plus b plus c. And I'll have 3 is equal to 4a plus 2b plus c. And now it's really easy to see which numbers here are going to be nice for us to cancel out. Really, a, b, or c is going to work out nicely. I'm going to choose to work with c, and so let's choose 2 of them to put together and cancel out. I'm going to choose, let's see, these first 2, or the first one and the last one. So I'm going to multiply the bottom equation by -1 so that my c's cancel out. So I have 7 equals 4a minus 2b plus c. And then multiplying this equation by -1, I get -3 equals -4a minus 2b minus c. Okay. And when I add these together, my c's cancel, and actually my a's cancel as well. So I have -4b is equal to 4. So actually I have b is equal to -1. Okay, and now I need to use this equation, and I need to choose one of the others. It really doesn't matter. In this particular case, I'm going to choose to use the bottom one. And so I can solve and get an equation where I can cancel out my c. I'm going to multiply my top equation by -1. So I'll have 2 equals -a minus b minus c, and 3 equals 4a plus 2b plus c. My c's cancel, and I have 1b and 3 a's equals 5. But I have a value for b, so I can actually, oops, this is supposed to be a plus sign, I can actually plug that in right here. So 5 equals 3a minus 1, adding 1 to both sides, dividing by 3, a is equal to 2. And now that I have my a and my b value, it'll be really easy for me to solve for c. So I'm going to use this middle equation here to solve for c. I have -2, I'm going to zoom out a little bit here. -2 equals 2 minus 1 plus c, and that'll give me c is equal to -3. But what they actually asked for here was find the quadratic equation given here whose graph passes through these 3 points. Well, now I have values for a, b, and c, so my answer is actually writing the equation. So we have y equals a, so 2x squared minus x minus 3, plugging in our a, b, and c, and that's it. And that's actually the end of section 7-2.